Hello guys, my name is Chris. I'll be discussing web work homework number 4, problem 11. So for this problem, we have a function yt satisfies the differential equation dy over dx equals y to the fourth plus 5y to the third minus 14y squared. What we want to find is 1, for what values of y is y increasing, 2, for what values of y is y decreasing, and 3, what are the constant solutions of the equation. Sometimes instead of constant solutions, they say equilibrium solutions. So if you ever see equilibrium solutions, it's the same thing. Do not get tripped up. So to start this problem, what we're going to do is we're going to write this equation down here. We'll start by doing that. So we have y to the fourth plus 5y to the third minus 14y squared, and then we're going to make it equal 0 because we're going to be solving for y. And this will give us our constant solutions. The reason I'm doing constant solutions first is I like to do constant solutions first, and then we graph it afterwards to find the increasing and decreasing values of y. So back down to here, we have this. What we're going to do is we're going to want to solve for y. The easiest way to do this is to factor out y and solve it that way. So to factor, first thing we have to do is factor out y squared. So when we factor out y squared, what we're going to get is y squared, in parentheses, y squared plus 5y minus 14 equals 0. From here, we're going to want to factor out this polynomial. And to do this, we need to find two numbers that multiply to negative 14, but put sum up to positive 5. Thinking of this, we have positive 7 positive 7 and negative 2. Summing up positive 7 and negative 2 gives you positive 5, and multiplying gives you negative 14. So what we're going to get from this is we're going to get y squared, y minus 7, or plus 7 I mean, and y minus 2 equals 0. From this, it's very simple. We just have to solve for each one of these. So we get pretty much y squared equals 0 right here, and that just means y equals 0. For this one, we get y plus 7 equals 0. When you subtract the 7 over, you're just going to get y equals negative 7. And for this one, we get y minus 2 equals 0. And when you add the 2 over, you're going to get y equals 2. So these are your constant solutions. So coming back up here, we're going to write for our solution, we're going to write negative 7, 0, and 2 for our constant solutions. Now, to find the values of y that are increasing and decreasing, as we need here, we're going to graph it and look at the graph. So I already have it graphed on Desmos over here, and basically everything underneath the x-axis is where the function is decreasing. Everything above the x-axis is where the function is increasing, because this is a graph of the differential equation, which is the rate. So basically, let's start with decreasing, okay? So everything under the x-axis is decreasing. So this is on the interval negative 7 to 0, because you see it's underneath the x-axis from negative 7 to 0, and from 0 to 2, okay? From 0 to 2, or from negative 7 to 0, and from 0 to 2. Okay, so what we're going to write here is we got negative 7 to 0. This is interval notation. U 0 to 2. And that's for our decreasing. Coming back up to here, all of this is increasing, okay? So we have from negative infinity, because it comes up to from negative infinity here, negative infinity to -7, and from 2 to infinity. So we're gonna have from negative infinity to -7, sorry for my 7, and u 2 to infinity. And those are our solutions for this problem. I hope you guys enjoyed. I hope you guys learned something about anything about autonomous differential equations. And good luck on the test.